Okay, our last video discussed rate of change. This video is going to discuss rate of change specifically relating to motion. This is something that's going to come up all year. Alright, we already have seen the relationship between position, velocity, acceleration. Okay, here's a new vocabulary word, or maybe you've already seen it in physics, displacement. That's just change in position. Alright, distance traveled, just how far did you go, that's over the total area. Average velocity, slope of the secant line, average, slope, secant line. You always have to connect those ideas. It may say instantaneous or it may not. If it doesn't say that, you know velocity at a time, we're referring to the slope of the tangent line or the derivative. Okay, speed is the absolute value of velocity. Now this part looks confusing, but it's not too bad. Alright, imagine you're moving forward, your velocity is positive, and then you hit the gas. Okay, you're driving in your car, you're moving forward, you hit the gas, your speed is going to increase. Okay, same thing maybe if you're going backwards down your driveway and you hit the gas, you're accelerating backwards. Again, your speed is increasing. Alright, if there are different signs, if you are moving, your car's moving forward and you brake, you're going to slow down. Okay? Or if your car's moving backwards and then you shifted into drive and hit the gas, your speed's going to decrease there. Alright, and you can read the last two. So there's always particle motion problems. There's almost always a question about particle motion on the open-ended part of the AP exam. So we're going to be getting a lot of practice of this. Find the displacement. That just means change in position during the first 2 seconds. Alright, well let's see where it started. Plug in 0. Looks like we started at 3. Okay, at 2, where did we end up? Plug in 2 to your function. I believe we get -1. So displacement, we're just finding the difference between our two positions. So -1 minus 3 equals -4 feet. I think feet, yes. Okay, so that means we went backwards 4 feet over those 2 seconds. That particle did. It went backwards 4 feet. Alright, when we talk about average velocity, we're talking about the slope of the secant line during the first 4 seconds. Alright, so S of 4, if we plug in 4, what do we end up with? Let's see, 3 I think, 16 minus 16 plus 3. S of 0, we already did that one, it's 3. So average velocity, we're going to do S of 4 minus S of 0 over 4 minus 0. We end up with 0 feet per second. So the average velocity was 0. Find the instantaneous velocity, rate when at t equals 4. Okay, we're talking about a derivative here. So remember, velocity is the derivative of our position function. So it's going to be 2t minus 4 using the power rule. So let's see what v of 4 is. That would be 8 minus 4 equals 4 feet per second. So at t equals 4, the velocity is increasing by 4 feet per second. That's how we would word that there. Now find the acceleration there. Again, acceleration is just the derivative of our velocity. So we just have to take the derivative of our velocity function, and it's going to be 2, no matter what. So a of 4, the acceleration rate at t equals 4, is going to be 2 feet per second squared. So that's saying that we are at t equals 4 seconds, the acceleration is increasing by 2 feet per second squared. Okay, at t equals 4, is the speed increasing or decreasing? Well, velocity at 4 was positive. The acceleration at 4 was positive. Since they have the same sign, the speed was increasing. Okay, and that's something that we mentioned up on the beginning of the notes. When is the particle moving to the right or to the left? At what values of t does the particle change direction? Alright, this is going to involve a little bit of work. Let's find out where it changes direction first. I'm going to do this over here on the side. Alright, just so I have a little bit more room. So we have t squared minus, I think our function is 4t plus 3. Let's figure out where it changes direction. Alright, where position is 0. So we have, I think I can factor that, right? T minus 3, t plus, or minus 1. Okay, I paused the video and not sure where I'm at, so I'll just keep going. T equals 3 here, t equals 1. So at those times, the particle is stopping. It's changing direction. Alright, so from, okay, so actually, let me just change my mind right here. I just thought about something. What does this function look like? Alright, so we just found out that it crosses the x-axis at 1 and 3. Alright, and since we don't, it's a parabola, it's going to be symmetrical. This minimum value right here, okay, or where is our velocity? 0. If you set that equal to 0, we're going to get 2, okay, at t equals 2. And if we plug that in, we get negative 1. This is our position function. Okay, so where is the particle moving, to the right or to the left? Where does it change direction? Well, if we look over here, the velocity from 0 to 2, the velocity or the slope is negative. So that means that I'm moving backwards. Alright, so it's moving left from 0 to 2. If you look on the other side, our velocity or our slope is positive. Okay, the slope is positive, so that's when we're moving to the right, when our slope is positive. So that would be from 2 to, we don't know, infinity. Doesn't know how far we're going here. And then where would it change direction? Well, right here, that's where our velocity is 0. We have a horizontal tangent line there, so that's at t equals 0. It changes direction. Alright, it's right there. That's where our velocity is 0. Our slope is 0. If your velocity is 0, you're not going anywhere. So right at that second, it's changing direction. Alright, so now using this graph, it's moving left from 0 to 2. So how far did it move? Well, we already did this, right? It moved 4 feet. So from t equals 0, whoops, so t equals 2, we moved 4 feet. So how far are we going to move from 2 to 4? Okay, if you plug in the numbers, you're going to see again it's 4 feet. So we're finding the total distance traveled. So we went 4 feet to the left, then we went 4 feet to the right. So our total distance is 8 feet. Okay, so technically we moved left, or the particle moved left 4 feet, but when we're talking about distance, we actually moved 4 feet. Alright, and so I can discuss this or answer any questions in class. Okay, so some big ideas that we just saw. When the velocity is positive, we're moving forward. Moving forward, okay? Whatever the forward direction is, it might be to the right, it might be to the left. So when velocity is negative, we're moving backwards, or in our case, to the left here. So take a look at this graph. Well, this is position. So if we're talking about velocity over here, alright, later we're going to have to talk about velocity. Let's just determine the slopes. It looks like on this line, the slope's 0. On this point, oops, the slope is negative 4. And here the slope is, looks like 1. And here the slope is 0. So let's look at From 0 to 2, what's happening? Well, our velocity is 0. That's just sitting here at this position 4 for 2 seconds. So when's the particle standing still? It's standing still from 0 to 2 seconds. Alright, what's happening here? Well, it's at position 4, and it's going backwards towards 2, then it's going to go towards 0, and then all the way down to -4. So it's the whole time, since the velocity is negative, okay, from 2 to 4, it's moving to the left. So it started at like 4 feet in the front. So here's our little person, or I mean our particle. It was just sitting there for the first 2 seconds, okay? Here, just sitting in a chair. Then, from 2 to 4, it went backwards, okay? If this is the front, sorry. Walking backwards, and then all of a sudden, at this second, we turned and moved forward. And then here we stood still. So when is the particle moving to the right? From 4 to 6, because our velocity is positive. And again, at the end, it's standing still from 6 to 7. So during the first 6 seconds, what is the displacement? Well, if we started when t equals 0, we started at 4. When t equals 6, we were at -2. Alright, so our displacement, -2 minus 4, change in position, is -6 feet. But how far did we travel? Well, from 0 to 2, we didn't travel anywhere. But from 2 to 4, we traveled 4 inches here. Oh, it's inches. Why did I put feet? Okay, sorry about that. It's 4 inches here, 4 inches here. So our distance there was 8 feet, and then we walked forward 2 more. Okay, so we have 8 plus 2 is 10 inches. That was our total distance traveled. Alright, what's the particle's velocity at t equals 5? Well, the slope is 1, so the velocity, so at t equals 5, the velocity is 1 inch per second. Okay, and that's because our slope is 1. Alright, and then we're going to end up with this, graphing the particle's velocity and speed. So velocity, from 0 to 2, our slope was 0. Okay, and we have an open interval because we don't really know what's going on there. Alright, our slope from 2 to 4 was -4, I believe, right? Let me look up. -4. So from 2 to 4, our slope was -4, or our velocity. From 4 to 6, it was 1. Okay, and from 6 to 7, we were just standing still again. Okay, and now speed. The only difference is it's the absolute value of velocity. So, again, still 0. Instead of being -4, that we were going 4 inches per second. The negative just tells us what direction. Okay, this is just 1 again. So we're moving forward 1 inch per second. Alright, and then the last part is still 0. Alright, what time is the particle moving the fastest? Well, where's this furthest from 0? Look at the speed here. And it looks like it would be the time from t equals 2 to t equals 4. Okay, so again, we'll work on this in class, come in with some questions, and let me know what you guys